Welcome back. In this session, I'm going to go over section 1 or chapter 1, whatever you prefer to call it. That is networking basics and the overview. It sounds a lot of hard things to memorize, but it really is things that you're probably already familiar with. So just sit back and relax, and I will try to explain this to you as best as I can. All of these and a lot more detail are going to be found in the videos that are in chapter 1 of Test Out. So let's go right into it. And we're in the networking overview. So these are the things that you're going to learn: IP address, subnet address, local area LAN, which you're probably already familiar with, metropolitan area network, MAN, wide area network, internet, intranet, and extranet. IP address and subnet addresses are things that you're going to constantly see throughout this course and throughout all of any kind of server with Active Directory courses and anything that has anything to do with networks, IP addresses, and MAC addresses, or how computers actually communicate with each other. A subnet address is used to determine what part of an IP address is the network and what part is the host. LAN is your local business network or your local home network. The metropolitan is if you go to the city of Miami and they have a metro network, that is that. The wide area WAN is a much broader one that it includes several MANs. Internet, you go into Microsoft, that's you're going through the internet. The intranet is something that's at work where you log in and automatically goes to your school or your work's homepage. And the extranet is used between two businesses. I'll show you that in a slide later on. So these are key definitions over here. So I already talked about the IP address identifies the network and the host, and the subnet is what actually determines what is us. There's a 32-bit subnet mask, and you'll see that when you get into subnetting, exactly how that works. We talked about a WAN that connects several LANs, and it's open to the public. Internet, intranet, and extranet, again, is accessed by authorized people. So if you have several branch offices, that would be considered an extranet. So again, key components of networks are obviously computers, devices such as printers, scanners. The network nodes are normally your computers, and they call them hosts. And you're going to connect to the server or connect to another computer, mostly through twisted pair, which is Cat5e cable or Cat6 cable, maybe Cat7. Fiber optic is more for between your school or your business and the internet, or between buildings or between floors. Wi-Fi, most offices, most businesses, most everything now have Wi-Fi, so your phone, your iPad, your laptops can all connect to it. The network interface you're going to learn, which is the cards itself, and the protocols such as TCP/IP are also, you're going to learn that that's what's used for communication. So this is a simple home or business without a network, all standalone computers. If somebody wants to print, he's own printer. If somebody wants a file, he has to have it on his file. So if computer A wants to open up something that's on computer B, he's going to need to either have computer B email it to him or take a flash drive and copy to that and then put it in here. With a network, you can see you have shared sources, such as the printer in this particular case. You can also share your own files in a peer-to-peer network. However, everybody can print to this one printer. And if this computer here needs something from this computer here, he can get permission to do it, but that has to get done on each and every computer, which obviously is not as convenient. They can show files over here. So benefits are mostly file sharing. Email, a lot is on an outside email server, voice over IP, webcast, all these things that you're used to. So a peer-to-peer is what I just showed you. So everything is connected here through some kind of device, which is a switch, or this could even be wireless. So they have access to each other's computers. They can see it, but in peer-to-peer, you have a hard drive that computer A wants to serve to computer C. he has to create a user account on this computer for the user account from here, give him permissions as to what he can or cannot access. Same thing with the printer. You have to give permission for people to be able to print to your printer. And you can see this guy is hiding behind here. Looks a little suspicious to me. Advantages, easy and inexpensive. That's the only thing. However, I don't really call it easy to implement. It might be easy to start up, but once you implement it, changing things is going to be a nightmare. And that's what not scalable and difficult to support are going to say. So these are, again, there is no decentralized storage at all, no centralized. So everything is stored separately. Client server, you see you have the one network server over here connected to a switch, and everybody is connected to the switch. The printer can also be connected to the switch, or it can be connected to the printer itself. Everybody has access, and through here you're going to use an operating system such as Server 2016, Server 2019 that has user accounts through Active Directory. Everybody logs in. So if you're here and you log in and your permissions are set and your files are set and your printers are set, then you go over here and log in. All your files are still available because they're stored on the server and you still can print. So that takes a little bit of setting up through group policy and other things that you'll find in the Active Directory courses. So you can see accessing this over here is a very simple matter. And another good advantage is Windows, and Mac. So you can connect to the same network on a Mac as you can with Windows. A little bit more tricky, but you can still do it. Very scalable, easy to support, and there's good data protection through NTFS and other ways, permissions. It is more expensive, so Windows is not cheap. Good old Microsoft is not a 50 billion or whatever amount of money they have company for nothing. And you just can't go in there and turn on the computer, type in next, and you have your network set up. So again, an individual network is just like a map of Miami or any other city. You know that you have these addresses here, 732, 39, and 744. And the way you determine them is 732 Oak Street. So Oak Street would be the network and 732 would be the host. And so we have an IP address. This is the network itself, and all these would be the host. So this might possibly be 192.168.1.1, 1.2, 1.3, 1.4, 1.5, 1.6, or whatever is determined. This is two separate networks. So you can have a 732 and a 732 on the same network. It's not possible, but on separate networks you can. However, you cannot access this house from this network without what is called a router. You'll learn that more in upcoming videos. Now you notice that the IP scheming is different. So the 192.168.1 cannot find anything on a 10.0.0 network or any other network that is not part of its own. Again, you'll learn more about that. The way the two communicate each other, which is a router. So router will take the network signals from one network and it will route it to another network. This is something that you're very familiar with. You go out to the internet. If you're in a business environment or you have Comcast, Xfinity, AT&T or whatever, you're going to go through some kind of router that usually will be a firewall. So the firewall is going to do two things. It's going to stop people from accessing bad sites from the inside, depending how you have it set up. But more important, it's going to block people from the outside of hacking into your network. So you can see somebody trying to do something and it gets bounced back. This is your private. It's going to have a private IP address, and then you're going to have a public. So this, the firewall will have, which is also a router, will have two ports, one on one network, which is the private network, and another which is on the public network. So it have two IP addresses. If you have a web server, that was also going to be accessible from the outside. Now, normally, the way it works is you have either two separate firewalls where you have a firewall here, and then it goes through the firewall to get to the web server to stop people from hacking in, or you have a separate port over here where anything that goes into the firewall, if it's for the web server and it's legitimate traffic, will be allowed to go into the actual web servers. Nothing is allowed to go in directly to the web server. That's called the demilitarized zone. Okay, and again, the intranet, this is a private web server for intranet for people of their own private business. And again, the extranet, as I was talking about before, you might have two separate offices. Through the internet is how they connect. Again, basically the same thing in here. So these are things for you to talk about on your own. When I post the PowerPoint, then you'll see these things there. You should really understand what all these things do. Okay, network topologies is really very simple. There's a lot of older technologies. I'm not going to spend a lot of time on the older ones, but it's basically how do they connect to each other and how does data flow. Basically, LAN is simple for local area network. A terminator is something that is in the older technology, the bus technology. You're going to have a 50 ohm terminator on each end of the cable to stop the data from linking. Okay, then you have two network topologies and physical and logical. You will explain that very detailed in the videos over here. Bus and ring are older technologies. A bus, everything is connected to this bus. There's one long cable, so there's a terminator here and a terminator there, and each one is going to be connected here. The downside of this thing, if there's a break in this cable here, the whole network gets down. If you take the terminator off here, the whole network goes down. In a ring, if you're trying to communicate with this computer here, it's going to go around here and say, are you this one? And then it's going to go to here, are you this one? This only has 3, but you might have 50 in here. And this is what's called star technology, where everything is connected to a local switch. Bus, ring, and the physical star you can see. Mesh is where everyone has some kind of connection to another computer. What's good about this, if I'm trying to communicate with this computer here and this cable gets broken, I can go through this computer to that computer, or this computer to that computer, or this computer, and that computer. So it's very hard to bring the whole network down. However, that's a lot of slowdown in here. Wireless mesh as well. And again, more class discussions. OSI model is really very simple, but it sounds extremely difficult. So basically, it's how you get from one computer to the other and what actually happens. So there's really 7 different layers. The application up top here is going to eventually communicate with the application layer up top here. So you'll see they are. If you want to remember how this goes, I was taught all people should try new Domino's pizza. However, there's several different other acronyms that you can use in here. That's just the one that I learned on, and you can use whatever you want here. So I will have a little mini discussion on what each and every one does in upcoming slides. So everything goes one layer at a time. This is the physical link between the two computers or the two networks, and this would be the network cable. So again, these are protocols and architecture in here. So these are physical items. These are not physical items. And again, application layers. The application layer really consists of the type of protocol that you're going to, such as HTTP, DNS. It's not a physical program such as Office or Outlook or PowerPoint or whatever it is. The presentation is the formatting and the encryption. A session creates the session, and you'll see more in the upcoming slides over here. So these are the common protocols in the application layer. FTP is file transport. FTP is trivial file transport. That's how you upload and download files. SMTP is how you send out a email. Again, presentation is for the syntax, which is really formatting, encryption, and compression. And normally you're going to be using SSL for the compression. The session ID creates a specific session for each time you go out. So for instance, if you click on Google and you go to MSN, that's one session ID. If you then click open up a new tab and go to another one, go to ESPN.com, it creates a separate session ID. That's how it knows how to go to which browser on your computer. And again, you'll see that UDP and TCP, that determines how are they going to communicate. One is connection full and one is connectionless. You'll see that more. Again, also puts in the port numbers. HTTP is 80. POP3 is 25 unless you're using IMAP, which is something different. Again, you'll see that a little bit more. The network determines the IP address and how to route it. So you can see that. Then the packets are created through the data link section, and that's actually broken in two separate frames. It has the MAC address and the CRC, which you'll see. That's the redundancy and the corrective, the silicon. I can barely pronounce it, but you'll see that in the videos, and it'll explain exactly. That's why you may get an error every now and doing that. And then the physical location is the network card and the cabling. So again, this is things for you to look at, the different protocols. TCP/IP is primarily what you're going to be looking at. So every time you communicate, it's really going to be on TCP/IP. That's the most common. So TCP is connection oriented. When you're connecting to another computer and you're communicating with it, the data has to be 100%. So there's error checking that goes through it. If you're using DDP, if you're going on to YouTube and you're downloading a video or you're watching a video or whatever you're doing, you don't want the error checking. So you need to make sure that it's UDP, otherwise it'll take forever and you may not even ever get it to download. HTTP is port 80, HTTPS is port 443. Whenever you go to your bank or you go to Amazon and order something, you're going to get a secure location. You're going to see that little lock in there, and instead of seeing HTTP, you'll see HTTPS, and it's going to use SSL and TSL encryption and security. You'll see that more when you get into the wireless. Again, more different protocols in here. SMTP and POP3 are for emails, as well as IMAP. The difference between IMAP and POP3, POP3 normally deletes it from the server and just downloads it to your computer. IMAP, everything flows off the server, but you can download it to your computer as well. DHCP is going to be used to get IP addresses on a local computer. So you're on a network, you're going to have a DHCP server, and that will actually sign the DHCP, the IP address to it. DNS is how you communicate to another computer through the name. So you type in Microsoft.com, it's going to take Microsoft.com, get the IP address from Microsoft.com from one of the DNS servers, and that's what it's actually going to communicate with. That saves you of having to know what the IP address is of Microsoft. Nobody's going to know that, especially when it changes. NDP, if you're on a network, your server should connect through NDP to a time protocol, to a time. There's several of them out there from the government. You might be through your firewall, and then each workstation will get their local time from the server. That way the entire network will have the same time. If you've taken a server course, then you know how important they all have to have for Active Directory to work properly. Okay, again, LDP, that's just a interfaces with Active Directory. I put this slide on for you to explain exactly what it does. And I also put this slide on here to explain what Active Directory is. So basically what you're going to use when you have a Windows server, you're going to use Active Directory to create user accounts, to create groups, to create group policy, all the different things, to do a print server. Everything is all going to go through Active Directory. And then again, this is more about the protocol suite. A lot of these slides are duplicates. SNMP is what you can use to look at your network and how things are flowing. A lot of things like Wireshark and stuff like that that sniff out problems to see how your network's doing, all use that. Telnet is very insecure. You'll see a lot of people connect from one computer to another computer through Telnet. That is dangerous, and most of them are disabled by default. Easier way is SSL, much more secure. ICMP is if you've ever done a ping test, that's how you know that computer is available. That must be turned on. Most servers will turn that off, so you can't have something called a ping of death or a Smurf attack or many of those other things that use pinging a computer. And again, the IGMP is the same thing, only it sends things out to a group of computers. Obviously, physical computer, specific network server. So you can see, again, all the different services that are available on networks. You can use an Apache web server, which is Linux, or IIS, which is Windows, to host a website. FTP allows you to communicate. Every time you go to a place and you download a file, you're doing that normally through FTP. DNS, so I want to go to Google. Well, I don't know what Google is, so I'm going to go to the DNS server, and Google is going to tell me what the IP address is. And again, DHCP, that's going to give out IP addresses. That's done for you automatically. Directory services, keep track of users, printers, shared folders. So when I have a teacher in my organization, they log into a computer, they have a shared folder that's really only shared with themselves. They have access to it. However, it's shared specifically with them. There are folders that all of the teachers have access to, and there's usually just read only. You don't want people overwriting stuff over here, but any teacher can access that shared folder. And again, same thing with printers. Then you also have priority of printers, where you might have somebody that's like a vice president or president, and then you might have some person that is just an office admin or whatever it is. And I use the term just loosely. What I mean is, in terms of the things that they're going to print, is not going to be normally as important as what a president is going to print. So if they both send something to the same job at the same time to the same printer, the one with the highest priority is going to get the job done first. And again, more of the same, how you connect remotely. So again, these are things that you should look at and understand. Numbering systems is basically, we're going to deal with binary, and we're going to deal with hexadecimal. And binary, obviously, 0s and 1. Hexadecimal is 0 to 15. So it's 0 to F. This is obviously base 10. You're very familiar with this. So if you have the 372, this is basically 2 to the 0, which is 1. 7 to the 10, which is 10 times 7. And 3 to the 10 to the 3, which is 100. So it's 372. And this explains it a little bit more. Binary is 0s and 1s. So you have 0, 1. This is 2 because it's 2 to the 1, 2 to the 1, which is 1, 2 actually, sorry. And this is 3. So even I get confused sometimes. Just remember, anything to the 0 is 1. So 2 to the 1 is going to be 2. And you can see how this all works. So this is 2 to the 0, which is 2 to the 1, which is 2. So this is 2 times 2 times 2, which is 8. So you can see the answer to this. If you take a look at it, this should be 1. This should be 3, because it would be 1 plus 2. And this you should add over here. So this is 1, 2, and 4. So it should be 4, 2, and 1. This would be 7 in here. And you can just see a little example how things go in here. And 2 to the 3 is 8 in here. And again, 2 to the 8 over here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, which is 256. This is 255, by the way, in here. So you're starting at 0. Hexadecimal, again, 0 to 15. And I will probably do a session on how to convert hexadecimal to decimal and decimal to hexadecimal. It's not really as challenging as it is, as it seems. And then again, you have binary and its equivalent in decimal. And we have here. So if you wanted to convert this number into decimal, you would go, okay, we have 1 to the, it's 128 if you put this in here, which is 1 to the 7th. This is 0, 1, 2, 3, 4, 5, 6, 7. So we have 128 plus 32 plus 8. That gives you 172. When you're doing subnet math, you really need to know this. Converting decimal is kind of just the exact opposite, decimal to binary. Start with the number 196. If you have this out, well, what is the highest number that will convert to in 196? We'll divide into it, and that's 128. So you put a 1 there. Subtract that, now we have 68. What's the highest number that will go into 68, which is 64? So you would put a 1 there. And then you would subtract 64 from that. I believe the next slide does that. There it does. Then you have 4 left. What is the next one, that highest, that will go into it? That would be 4. So you would put a 1 there and all zeros here. And that's all that's left over. So that's how you would do that. A MAC address is going to have 6 groups of 2 hexadecimal numbers. The first 3 groups are the address or the sign to the manufacturer, and the rest is the actual ID of the network card. Every network card will have a unique MAC address, and it's hard-coded into the firmware. You'll see that in the video itself. And again, here's some discussions. That's it on this. Please let me know if you have any questions at all, and I will be there for you as much as I can. Hope you have a wonderful, wonderful, wonderful day.